AI models have come a long way, but OpenAI's latest brainchild, O1 Preview, is an entirely different beast. The AI model isn't just breaking new grounds, it's redefining what AI can do. O1 Preview is thinking, reasoning, and creating with a level of intelligence we've never seen before. This isn't just an upgrade, it's a leap into the future, where AI is no longer just a tool, but a powerful mind of its own, reshaping industries and rewriting the limits of possibility. In this video, we will review some of the mind-blowing capabilities and features of the new AI model from OpenAI. The first and one of the most intriguing capabilities of OpenAI's latest AI model is its ability to tackle complex linguistic puzzles that go beyond simple translation. This model demonstrates an impressive aptitude for deciphering and interpreting heavily modified or corrupted text, as seen in this clip.
Here I pasted in the prompt, and I'm asking the model to translate this badly corrupted Korean sentence to English.
Instead of just attempting a direct translation, the AI can analyze the underlying structure of the corrupted text, identify patterns, and essentially reverse engineer the encryption or modification process as we see in this clip.
In the same thing, unlike GPT-4o, this model starts thinking through this problem before outputting the answer. So it's decoding the garbled text. So that's actually the right approach, because I gave a translation task, but the underlying task is actually decoding this problem. So it started off with the right path, and then I'm examining this text, deciphering the text. Deciphering is actually the right verb to use here, enhancing the translation, and then actually it starts unpacking some part of it. So here, 모음과 자음의 다양한 변환으로, and so on. This is already an decrypted part of this, and then once the model figures it out, that part, everything else is just easy enough. So it does the other sentence too, and so let's close this thought. So it thought for 15 seconds. The final translation the model output is, no translator on earth can do this, but Koreans can easily recognize it. There's a method of encrypting Hangul by inputting various transformations of vowels and consonants. It creates a way to make it look different on the surface. It can even confuse AI models.
What's particularly noteworthy is how the model breaks down its approach step by step, almost like a detective piecing together clues. This methodical reasoning process allows it to handle tasks that combine linguistic knowledge with logical deduction, a blend of skills that's quite human-like in its complexity. The implications of this capability are far-reaching. It suggests that the AI model could potentially be applied to a wide range of fields where decoding or decrypting modified information is crucial. This could include areas like cryptography, forensic linguistics, or even historical language analysis where texts might be partially corrupted or altered over time. OpenAI's latest AI model demonstrates another impressive capability, which is its ability to code video games from prompts. This model showcases an enhanced ability to understand complex instructions and translate them into functional code. When tasked with creating a game like Squirrel Finder, the AI handled multiple elements simultaneously.
So let's try pasting this in. And to give a brief overview of the prompt, the game Squirrel Finder basically has a koala that you can move using the arrow keys. Strawberries spawn every second and they bounce around, and you want to avoid the strawberries. After 3 seconds, a squirrel icon comes up, and you want to find the squirrel to win.
It incorporated game mechanics, like moving a character with arrow keys, managed spawning and behavior of game objects, like bouncing strawberries, implemented win conditions, and even added UI elements like instructions and branding.
And you could see that during its thinking process, it is gathering details on the game's layout, mapping out the instructions, setting up the screen, etc. And so here's the code that it gave, and I will paste it into a window, and we'll see if it works. So you've seen there's instructions, and let's try to play the game.
One of the key strengths of this AI model is its thinking before doing approach. When given a coding prompt, the model doesn't immediately start generating code. Instead, it takes time to process the requirements, plan the structure, and ensure that all constraints are met. This methodical approach often results in more coherent and functional code. It is also important to mention the AI's ability to create a fully functional game from a single prompt. This suggests a deep understanding of game development concepts, programming logic, and user interface design. The model can apparently integrate various programming elements, from character movement and collision detection to timers and game state management, into a cohesive whole. One of the standout capabilities of OpenAI's new model, O1 Preview, is its ability to assist experts like geneticists in handling complex cases with ease and efficiency. In this case, we hear from Dr. Catherine Brownstein, a geneticist at Boston Children's Hospital, who highlights how this AI model can revolutionize the way researchers like her tackle challenging rare medical cases in this video.
When before I would look up an article and then look up another article and then look up another article. Chat with reasoning is so much easier to use. It's just a quick prompt to summarize it for me and then summarize this part for me. It's just way, way faster.
With around 20,000 genes in the human genome, it's practically impossible for any human expert to have comprehensive knowledge of every single one. However, AI can rapidly access and analyze this enormous data set, providing researchers with relevant information almost instantly. Another crucial feature is the AI model's capacity to make connections between genetic variations and potential health impacts. In this case, the AI model was able to link a specific gene to bladder health and even suggest possible mechanisms, both increased and decreased activity, by which a genetic variant might cause symptoms as seen here.
Case of excruciating pain in their bladder. We can't figure out why. So I can go here and say, can you tell me about citrate synthase? And it tells me that it is expressed in the bladder and it could potentially be related to bladder health. So the decreased citrate synthase activity, oh, this is really smart because I don't know from this variant if it's like knocking down activity or causing too much activity. It's actually really hard to figure that out sometimes. And so it gives both options. So I can think about both ways that it could be going. That's actually really cool.
The AI also shows promise in helping researchers avoid unproductive rabbit holes in their investigations. By providing relevant, focused information, it can help increase the efficiency of research efforts, allowing scientists to spend more time on promising leads rather than dead ends. Another exciting capability of OpenAI's O1 Preview model is its ability to handle complex reasoning tasks, such as intricate puzzles and logic problems, with a human-like thought process. Unlike previous models that excel at language-based tasks, but sometimes fall short when it comes to problems involving deeper logical steps, O1 Preview takes a more thoughtful approach. It doesn't just race to an answer, it reasons its way through. We see an example in this clip.
The riddle reads as, a princess is as old as the prince will be when the princess is twice as old as the prince was when the princess's age was half the sum of their present age.
In this example, we have a riddle that's filled with layers of conditions and tricky language. The challenge for most AI models has been understanding the underlying structure of such a problem and then solving it in a step-by-step manner, much like how humans would. Traditional models might struggle to translate a complex question into actionable logic, but O1 Preview tackles this by thinking through the problem. It decodes the information, identifies the variables involved, and walks through the solution in a way that's both methodical and transparent as shown here.
And after a while, I hope the model will give us a correct answer here. The model is still thinking about it. It's not the easiest problem, but we got the answer just right now. The model also walks us through the solution in this case. What are the variables? What are the conditions? How to translate this problem into English, and how to solve those equations where they are just real time. together. We even got a message about verification, and we got the answer where the prince's age is 6 times k for any.
This type of reasoning opens up a wide range of possibilities for practical applications. Imagine a student facing a challenging word problem in math, or a professional working through a complicated decision-making process. With O1 Preview, the AI not only provides an answer, but also explains the process behind it. This transparency allows users to follow the logic, offering not just a solution, but also an understanding of how that solution was reached. In practical terms, this means the model can be applied to fields like education, research, and even creative industries, where logic and reasoning are essential. Whether it's breaking down a complex legal argument, solving a tough math problem, or even navigating through scientific puzzles, O1 Preview can deliver more than just a quick fix. It offers thoughtful and well-reasoned solutions. Another exciting capabilities of OpenAI's O1 Preview is its ability to tackle complex mathematical puzzles and logical problems, such as nonograms as shown by Mason Meyer, one of the researchers that worked on the model. He introduced nonograms here.
One of my favorite puzzles that I would do when I was a little kid is called a nonogram, where you're given an empty grid and then some numerical clues that tell you which squares in the grid you have to fill in. And I thought we could have the model play a little game where it first generates a puzzle to solve, then we ask,
O1 Preview can not only solve these puzzles but also generate them. The model first creates a 5x5 nonogram puzzle where the final result should form the letter M.
Generate, say, a 5x5 nonogram, where the final answer is the letter M. We'll see what it comes up with. All right, we see it just gave us a little puzzle.
After generating the puzzle, the model solves it in another instance and successfully visualizes the answer in a clear and structured way.
This puzzle doesn't look like it's too hard, but the way that a nonogram works is for each row and each column, you're given a list of numbers, and the numbers tell you how many squares are filled in. And if the squares are consecutive, then you'll see like a 2 for 2 consecutive squares. If there's a space between them, you'll see a 1, 1. And so you're supposed to just try to figure out which squares do I indeed have to fill in. And it looks like the model got this right. Illustrated a nice little letter M.
What's impressive here is how the model handles the underlying logic required for solving a nonogram. These puzzles are not straightforward. They involve cross-referencing clues for rows and columns, making guesses, and then backtracking if a guess leads to a contradiction. Essentially, it's a problem-solving process that mimics how we, as humans, approach similar logic games like Sudoku or crosswords. The O1 Preview model shines in tasks like these, where it needs to navigate through a search space of possibilities. It can refine its guesses, detect contradictions, and adjust its approach in real time. This capability is not just useful for games and puzzles, but also has broader applications in fields that require reasoning through interconnected variables, such as scheduling, decision-making, and optimization problems. What's even more fascinating is that this is just one type of reasoning task the model can handle. Its ability to think through multiple steps, consider dependencies, and revise its approach makes it a powerful tool for solving complex challenges across many domains. And with these kinds of capabilities, it's clear that models like O1 Preview are opening up new possibilities for AI problem solving, whether it's for entertainment, education, or more practical applications. Another remarkable capability of OpenAI's O1 Preview model is its ability to handle highly complex and specialized tasks like quantum physics reasoning. Quantum physics, being one of the most intricate fields of study, involves a deep understanding of mathematical principles, abstract concepts, and the behavior of subatomic particles. Previous AI models, even the highly advanced GPT-4, would often struggle with such tasks.
Or previous models like GPT-4 would very likely fail in this task.
However, O1 Preview demonstrates an impressive ability to engage with these high-level problems. It can provide detailed, correct mathematical answers and apply complex quantum operators, tasks that require more than just basic language processing. This is particularly useful for researchers or students working in the field of quantum mechanics who need precise and accurate assistance when dealing with abstract problems. What stands out with O1 Preview is not just its ability to give correct answers, but also the transparency of its reasoning. It doesn't just offer an output. You can follow the steps it took to get there. This makes the AI's process more trustworthy, especially in a field like quantum physics, where precision and detailed understanding are crucial. Researchers no longer have to blindly trust the result. They can examine the reasoning behind it, making sure it aligns with their expectations. This opens up a wide range of possibilities for its use in scientific research, particularly in areas where accurate mathematical modeling and theoretical understanding are key. From exploring quantum phenomena to building new technologies based on quantum principles, O1 Preview provides a tool that could accelerate both learning and innovation. Now, the underlying principle or feature that makes all of these capabilities possible is the model's improvement in common sense reasoning, particularly when it comes to understanding physical objects and their behavior. Earlier models like GPT-4 often stumbled when asked about basic physics scenarios, such as where an object would be after a series of actions, even though it's something a human can easily figure out.
Of the problem I would like to show is an interesting common sense reasoning thing that all the previous type of large language models didn't do that great, which is about physics and about physical objects and their relationships.
In this case, the model is tested with a simple yet tricky problem. If a strawberry is placed inside a cup, and the cup is then flipped upside down and placed inside a microwave, where is the strawberry? While this seems straightforward, past language models struggled because they weren't designed to reason through physical interactions between objects. They could give vague or incorrect answers, as they weren't equipped to visualize or logically analyze physical events. In contrast, O1 Preview can approach this problem with much more precision. It not only gives the correct answer, understanding that the strawberry remains inside the upside-down cup, but also provides a detailed explanation for why that happens, reasoning through the physics of the situation. The model takes extra time to think about the relationships between the objects involved, giving it a deeper understanding of the problem before it delivers an answer. What's even more fascinating is that the model can show its reasoning process, giving us a glimpse into how it breaks down and analyzes the problem step by step. This allows users to follow along, making it easier to trust and validate the answer, which is crucial in scenarios involving physical reasoning. This new AI model also provides a significant leap forward in the field of programming and software development. This advancement is particularly exciting because it has the potential to dramatically change how we approach coding and software creation. Scott Wu, the CEO and co-founder of Cognition AI, provides some fascinating insights into this new technology here.
Programming is that it's changed in shape over and over the last 50 years. Programming used to be punch cards, and people used to, that was how it was first done, right? Along the way, there are all these different technologies, the internet and cloud and mobile and so on. I'd say as a whole, it's only gotten easier to produce code and to produce real programs. Being able to write code out line by line is one thing, but also being able to understand and interpret logs, being able to navigate and run commands that actually, affect the real world is a big part of programming. This new model O1 is really able to process and make decisions in a more human-like way. We're getting a glimpse into a new generation of models. We worked closely with OpenAI on iterating on it and giving our feedback and testing it out. What we found was that O1 was just incredible at this kind of reasoning.
He points out that programming has evolved significantly over the past 50 years, from punch cards to today's advanced systems. Each iteration has made it easier to produce code and create real programs. Now, with AI models like O1 Preview, we're seeing another major shift in this evolution. What sets O1 Preview apart is its ability to process information and make decisions in a more human-like way. This isn't just about writing code line by line. It's about understanding and interpreting logs, navigating systems, and executing commands that have real-world effects. These are complex tasks that typically require human-level reasoning and decision-making. One of the most intriguing applications of this technology is Cognition AI's project called Devin, described as the first fully autonomous software agent. Devin can tackle programming tasks from scratch, approaching problems in a way similar to human software engineers. This includes planning out approaches to problems, adapting when initial attempts fail, and making decisions on the fly about how to proceed. The example given, where Devin analyzes the sentiment of a tweet using various machine learning services, showcases the AI's ability to plan, troubleshoot, and execute complex tasks. When one method of fetching the tweet failed, Devin autonomously decided to try a different approach using an API. This kind of adaptive problem-solving is remarkably human-like and represents a significant advancement in AI capabilities. The implications of this technology are profound. As Wu points out, it could allow every human to build much more, much faster. The core of programming has always been about turning ideas into reality, and tools like O1 Preview and Devin could dramatically lower the barriers to entry for software development. In our next video, we dive into how China's new AI model, dubbed the Sora Killer, shocked the entire industry.